We let the geometric series, we let the first term be x, and so the geometric series will look like this, which means that S is, there's that formula A over 1 minus R. I don't know how I feel about the formula. I would rather, most of the time, I would just rather you do this, to be honest. This seems preferential. And then just like S times x minus 1 equals x squared. S. Oh, well. Okay. So S equals A over 1 minus R. The initial term is x. The ratio is 1 over x because the second term is 1. And this equals x squared over x minus 1. And yeah, so basically we're trying to find the smallest value of x such that we can still solve this equation to get a value of x. And so yeah, so we want to find the smallest value of s for which we can solve it. So why not just try to solve it? So Sx, I'll just hijack this. So x minus x equals x squared. So that means that x squared minus sx plus s equals 0. So x equals s plus or minus square root of s squared minus 4s over 2. And okay, so clearly s is at least 1 because one of the terms is 1 and all of the values are, and all of the values are positive. So clearly s is at least 1, which means that s is greater than -4, which means that s squared minus 4s implies that s is at least 4. Because like otherwise we could, if we had s was really negative, s squared minus 4s would also be positive regardless, which would be not really what we're looking for. So yeah, instead we still need that s squared minus 4s is greater than or equal to 0 in order for us to be able to solve this quadratic, which means that s is at least 4. And so s is at least 4 is like basically our conjectured answer. Just to make sure, if we plug in s equals 4, we get x squared minus 4x plus 4 equals 0, or x minus 2 squared equals 0. And yeah, this corresponds to this sequence, which is pretty famously equal to 4.